Good afternoon, all. Am I audible to you?
Yes, sir.
Students are not joining, no? Right. 97 students, and out of 97, only we got 75. What other students are doing? Now, gate is over also. It's over also, but still are not joining. Divesh, can you put like message there in the group to join the class immediately? Those who has not joined yet.
Okay, sir.
So today I'll continue with that numericals. Like regarding that mini project, no? So as I was, you have to prepare that work plan, what you are going to do. So prepare it accordingly, the work plan and objective. What will be the main objective? And do this one like by another 2 days. Okay. So you have to discuss in your group. You have to finalize it. The main objective, the work plan, main work plan. So there will be like 2 objectives, kind of 2 or 3, minimum 2. So should be outcome based. With some outcome, we have to come out. You should be very specific. Like from each and every objectives, we have to get some notable results, notable outcome. Objective should be that way. So, okay. Yogesh, and now you can share the PPT. You can start. You can continue.
Okay, sir. Good afternoon, students. Today we will discuss wind speed estimation for different types of train. First, note down this table in your notebook. This table gives some approximate surface reference length for various type of terrain. So left side of table gives terrain description and the right side gives values of Z naught means surface reference length for terrain. So for very smooth or ice or mud, Z naught is equal to 0.01 in mm. Calm and open sea 0.20 and so on. So we use these values in first logarithmic profile law and second power law. So in this question, determine the wind speed at a height of 40 meter over surface terrain with a few trees. So terrain type is given with a few trees. So we use value for few trees 100 mm. So Z naught is equal to 0.1 meter. If the wind speed at a height of 10 meter is known to be 5 meter per second. So we have to calculate the wind speed at a height of 40 meter. And we have given two wind speed at 10 meter which is equal to 5 meter per second. For your estimate, use two different wind speed estimation methods. So we use first method as simple logarithmic wind profile law and second method as power law. In part B, using the same methods as part A, determine the wind speed at 40 meter if the trees were all removed from the train. So in this part, the trees were removed. So Z naught is equal to 0.01 meter. So in this table, if we remove trees, then we have rough pasture, which is equal to 10 mm. Z naught is equal to 10 mm. So convert in meter. So Z naught is equal to 0.01 meter. So write down this question in notebook. In part A, we use first method as simple logarithmic wind profile. So according to logarithmic profile law, uz by uzr equal to ln z by z naught divided by ln zr by z naught. Here z is the height for which we have to estimate the wind speed, and zr is the reference height where velocity is given. That is in first part 10 meter, zr is equal to 10 meter and velocity is 5 meter per second. ln z by z naught divided by ln zr by z naught. Z naught is the surface reference length, and we calculate z naught from this table. So use this formula, logarithmic profile law, and calculate the wind speed at 40 meter height. uz uzr is 5 meter per second, z is equal to 40 meter, and z naught is equal to 0.1 meter, and zr equal to 10 meter. Calculate wind speed uz u40. So by using the logarithmic profile law, we get the value of U40 approximately 6.51 meter per second. Now we use second method as a power law. Assume a power law wind speed profile. The wind speed at a height of 40 meter is determined as, according to power law, uz by uzr equal to z by zr to the power alpha. Here uz is the wind speed at a height of z and uzr is the reference wind speed at height zr and alpha is the power law exponent. So early work on this subject showed that under certain conditions alpha is equal to 1 by 7, indicating a correspondence between wind profiles and flow over flat plates. So we use alpha equal to 1 by 7. So alpha is equal to 1 by 7, which is equal to 0.142. So use this formula and take value of alpha equal to 0.142 and calculate wind speed. Note this formula and these definitions in your notebook. Now in part B, using the same methods as part A, means logarithmic profile law and power law. Determine the wind speed at 40 meter if the trees were all removed from the terrain. So we use only Z naught value in logarithmic profile law. In power law, there is no Z naught. So according to power law, if we use power law in this method, in this question, so we get the value same as in part A, 6.09 meter per second. Only we get different value for logarithmic profile law. With trees cut down, assume a rough pasture surface terrain. So Z naught is equal to 10 mm equal to 0.01 meter. So use logarithmic profile law and U40 we get 6 meter per second. And if we use power law, we still assume alpha equal to 1 by 7. So we get the same value for U40, 6.09 meter per second. So calculate U40 according to logarithmic profile law. Now read and write this question. A 30-meter diameter wind turbine is placed on a 50-meter tower in terrain with a power law coefficient alpha of 0.2. Find the ratio of available power in the wind at the highest point of the rotor to its lowest point. So read this question and try to solve it. So in this question, we have to determine wind speed at the highest point of the rotor and its lowest point of the rotor. Then we calculate wind speed ratio and power ratio. So diameter of the turbine is given as 30 meter and hub height is 50 meter and alpha is equal to 0.2. So for lowest point, Z low is equal to 50 minus the radius of the rotor, 50 meter minus 15 meter. So we get 35 meter as Z low and Z high is equal to 50 plus 15 equal to 65 meter. So now according to power law, we use Z low and Z high, UZ high divided by UZ low equal to Z high divided by Z low to the power alpha. So we get value 1.13 of UZ high by UZ low, that is wind speed ratio. And we know the power available in the wind is equal to half rho A U cube, which depends on cube of the velocity. So Pz high divided by Pz low equal to Uz high divided by Uz low to the power 3. So we get, we use 1.13 as Uz high divided by Uz low and we get the value for power ratio equal to 1.44. So practice similar kind of questions based on these formula, logarithmic profile law and power law. In logarithmic profile law, we use table for surface roughness length. In power law, we use simple formula uz by uzr equal to z by zr to the power alpha.
Class over. Just wait. Yes, it's over from your side.
Yes, sir.
So, practice this kind of numericals. It is important for your exam also, for mid-semester exam. And that one PDF file of 94 pages that what I have provided there in the Google Classroom. That is also important. You have to go through that one, numericals and paper part also, and the topics also. So from the topic also, some question may come there in the exam. Okay. Tomorrow we are having class again, isn't it? From 12 to 1. Then before that, you just decide the objectives and work plan. It will be group wise. Correct. So work on that. Then, okay, then we'll meet tomorrow.